A student has asked for help with these questions. Here we're provided with a demand and a supply schedule showing the quantities demanded and the quantities supplied at various prices, and here we're talking about the bread market. We're assuming it's a highly competitive or perfectly competitive market, and that's why we're able to use the demand-supply cross model. The first question is, what is the equilibrium price of bread? Well, we know that the equilibrium price is the price at which the quantity demanded equals the quantity supplied, and you can simply look at the table to find where that is. It's here. The price of $6, the quantity demanded is 4,000 and the quantity supplied is 4,000. Now that's straightforward enough, but for the rest of the questions it would be very useful if we draw some graphs based on the data we've been provided with, because we're going to be asked to calculate the consumer surplus, deadweight loss and producer surplus as part of an economic welfare analysis of this market. So first we need to plot the points that are in the table. So there's the demand schedule points, and there are the supply schedule points. We can just join the dots and we've got a demand curve and a supply curve. The equilibrium is going to be at the point where the quantity demanded equals quantity supplied, or in graphical terms, where the two curves intersect. Here, the price of $6, the quantity of 4,000. Our next question is, what's the total economic welfare generated by the free market for bread? Well, the economic welfare area is going to be composed of the consumer and producer surpluses. And so that's going to be the area under the demand curve, the highest prices consumers are willing to pay, up to the quantity sold, which is at equilibrium, and above the supply curve, which is the lowest prices that producers would be willing to accept. That area there is our total economic welfare area in equilibrium. How do we calculate the area of that? Well, it's very simple. We just take this rectangle that encloses the triangle and we just calculate the area of that rectangle. The height multiplied by the width, cut in half, gives us the area of that triangle. So $8 multiplied by 4,000, cut in half, divided by 2, equals $16,000. That's the total economic welfare area. Our next question is premised on the following slightly odd scenario. Suppose that somehow all the bakeries come to an agreement to charge $8 for a loaf of bread. So here what we're going to have to assume is that all the bakeries get together and they all agree to restrict their output, to restrict supply, until consumers are willing to pay $8 per loaf. So we're asking what happens to the consumer surplus when that occurs. So here we have the firms restricting their output to 2,000 loaves, and consumers are willing to pay $8 per loaf given by the demand curve for the 2,000. Where's the consumer surplus going to be? Bear in mind the consumer surplus used to be the area under the demand curve up to the equilibrium output and above the equilibrium price. It was a large triangle, right? But now what is it going to be? Well, it's the area under the demand curve up to the new lower quantity supplied to the market and above the new higher price. That area there is our new consumer surplus area. How do we calculate it? The same way as we calculated the previous area. We'll take a rectangle, height of 2 times the width of 2,000, cut it in half, and there you've got the area of that consumer surplus triangle, $2,000. Easy peasy lemon squeezy. Our next question is, what would be the deadweight loss? Okay, so if you remember, we've got a total economic welfare area in equilibrium, that's this very large triangle, but now the quantity bought and sold has been restricted from 4,000 down to 2,000, which means this triangle here, this part of the economic welfare, has been lost. This is the deadweight loss of economic welfare. How do we calculate that? The same way as we calculated the larger triangle. So 4 times 2,000 divided by 2 is $4,000 deadweight loss. That's lost economic welfare. Do the bakeries collectively gain from their agreement? Well, in order to figure that out, we need to compare what the producer surplus is under the collusive agreement versus what the producer surplus was when the market was in equilibrium. So let's calculate our producer surplus. It's this area here, the area above the supply curve, up to the quantity that will be supplied to the market, and below the price that's being charged of $8. Now that's an odd shaped thing, so let's break it up into 2 bits. So we'll take this part here, and we're interested in the P there, and we'll take this part here, and we'll call that P star, and P plus P star together make up the total economic welfare area for the producers. So height times width for P star, obviously we don't divide that by 2, and height times width for P, but we do cut that in half. So here's what we get. P star is $8,000 plus P is $2,000. So the total economic welfare area is $10,000 due to this collusive behaviour. Now we need to compare that to what the producer surplus would have been under equilibrium conditions. So it's this area here. How do we find that? The same way as we found it before. $8,000. Alright, so which is better? $8,000 or $10,000 producer surplus due to the collusive agreement? Obviously, the latter is superior. The last question is a slightly curly question. Is such an agreement really likely in a nearly perfectly competitive market? The standard answer to this question is no, it's not likely. The collusive agreement would not occur. Why? Well, first, there's simply too many firms in the market to organise cooperatively. You've got oodles and oodles and oodles of firms. They don't all know of each other's existence necessarily. There's so many of them, and just to get together and hammer out an agreement would be a logistical nightmare and would be extremely costly, so it wouldn't occur. That would be the basic idea. Also, there's an incentive to cheat on a collusive agreement. Say a collusive agreement did eventually get organised somehow. Each individual firm has an incentive to produce more than they are supposed to, according to the collusive agreement. Because by producing a bit more and still selling at the collusive price, you'd make a larger profit. Now, if every firm is thinking that, I'll produce a bit more than what I'm supposed to, the collusive agreement breaks down and everyone will end up back at equilibrium, making a smaller profit and a smaller producer surplus. Remember, profit and producer surplus are not the same thing. Furthermore, even if that didn't occur, there's an incentive for new firms who aren't a party to that agreement to enter the market, and so the collusive agreement would break down again. Now, that's a perfectly fine and respectable answer. However, if you start thinking about it a little bit, there's something unsatisfactory about it. And that's because of 2 things. One is we assume for perfect competition that firms have perfect knowledge and there's perfect mobility of resources. So there really should be no costs associated with organising to cooperate with each other. It doesn't really matter that there are oodles and oodles of firms, because if firms possess perfect knowledge, they know all of the other firms that are in existence. So, assuming that, then there should really be no costs associated with cooperating with each other. That shouldn't be a barrier. Also, this is a repeated game, like most markets. It's not like it's a one-shot game where you set up your collusive agreement and then you decide whether to cheat on the agreement or not. And once you've cheated on the agreement, then the game's over. It's not like that. This is a game which is going to be played every day, every week, every month, every year. So when you have that kind of repeated game that has no terminal point, then it's really, for each firm, a choice between, do I want to stick to the collusive agreement and make a larger profit than otherwise, and make a larger producer surplus than otherwise? Or do I want to cheat on the agreement? Remember, everyone's thinking this. Cheat on the agreement and effectively end up back at equilibrium, making a smaller profit and a smaller producer surplus. That's really the choice. Do you want a larger producer surplus or a smaller producer surplus? Right? Do you want to continue cooperating, or do you want to cheat? And the firms know this, and of course they would. They have perfect knowledge and they're perfectly good calculators. Then they would immediately realise to act in their own self-interest. In the long run, they should collude. So one would theoretically, perhaps you could make the case, you might expect collusion to occur. Now, obviously in the real world, that's probably not going to happen, because in the real world there isn't perfect knowledge, and there would be substantial costs associated with acting cooperatively. And also, it's possible for firms to cheat on an agreement for some period of time without anyone else really cottoning on to what's going on. So, in the real world, we wouldn't expect to see a cooperative agreement occurring for a highly competitive market. And even if that did get up, we would expect to see cheating on that agreement and eventually the collusive agreement collapsing. Nonetheless, even in reality, we can find the occasional example where precisely this happens. You have a highly competitive market and yet collusion occurs. So here I'm thinking about the dairy industry in Queensland, New South Wales and Victoria in the late 19th century, early 20th century. Dairy farming and the production of dairy products, chiefly milk, was highly competitive. Many farmers, all producing essentially the same product, all having essentially the same knowledge, the same technology available, and so on. Yet, at some point, somehow, they got together and formed a cooperative, and these became known as dairy cooperatives. There was the New South Wales Dairy Cooperative and the Queensland Dairy Cooperative, Victorian Dairy Cooperative, in which all of the dairy farmers got together and colluded. They formed a kind of union, in a sense, in which they agreed to work together. Everyone pitched in, put in money to build factories and to build distribution networks and to share knowledge and information in order to gain control over the quantity of milk and the quantity of dairy products supplied to the city markets, and thereby control the prices of milk and dairy products in order to ensure a stable and secure income in the long run for everyone. And this kind of collusive agreement became institutionalized. Right? So when you see the logo these days for dairy farmers, that's the grandchild of this cooperative dairy farmers institution which was formed, that grew out of a competitive environment in which, in a textbook sense, you would not expect to occur at all.